Welcome back, everybody. In this video, we're going to be talking about arrays. Now, in computer science and computer programming, there are many different types of collections, but arrays are the most fundamental, basic. You kind of start here when it comes to collections data structure. They can be very useful. They hold many elements as opposed to just, like for example, an integer. Int a equals 5. This integer holds one value. An array is going to hold many values. I've gone ahead and set up some code here that is what you would see in a very, 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 very basic level programmer's program. I have a whole bunch of integers and I print them out. But this takes up a lot of space. And this is just a few. This is what, six values? What happens if this was 100? Going back to my example of that. If this was 100 elements, this would be 200 lines of code and it would be just an absolute mess. With arrays, we can simplify this process much more straightforward than what this is. So let's go ahead and do that. So I'm going to keep this up here for now, just to use the same values. But I'm going to go here and I'm going to create a new array. Now, to create an array, you start with the same data type that you want. I want to create an array of integers, so I'm going to start with an integer. But you put these square brackets after it. These square brackets indicate that the data structure that you're making is not an integer, it's in fact an array of integers. Just like our other data structures, you give it a name. So my array, and then in this scenario, you would usually say, 5 or whatever if I was creating an integer. But because it's an array, because it's a reference type, we actually have to create a new object. We can't just store 5 in an integer. It's not a primitive type. An array is an object type. That's when the keyword new comes into play. So we're going to create a new int array. Now it's going to get mad at me specifically because an array creation must have a size or an initializer. So I'm going to give it a size in this case. Let's give it 6. So I have now allocated space. As soon as this line is called, I have allocated space in memory for 6 integers. Now, these 6 integers exist, but they're all effectively 0. So let's print it out. Let's print out the first one just to test it out. So console.writeLine my array, and like I said previously with the strings, a string is an array of characters. You index it with these square brackets. So I want the very first element in this array. I'm going to print it out, and I'm actually going to comment this out. And you can see it prints out 0. That's because an integer's default value is 0. We actually haven't set any values here. So let's go ahead and do that. So I'm going to say my array 0 equals 5. And then when I try to print it out now, you're going to see that I actually set the value of my array at index 0 to the value of 5. So let's go ahead and do some copy pasting here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And remember, 0, 1, 2, 3, 4, 5, that's still 6 elements. As engineers, we start counting at 0. So we're going to go 5, 2, 10, 9, 15, and another 10. So I'm going to run it again, and we're still going to get 5. However, I've gone through and I've actually set the data in this array. So let's use some tool that we've previously used to help with this, a for loop. So for, tab, and right here, it says length. This is kind of a hint towards something. And remember, this is Visual Studio automatically generating this for loop. This is a hint here. If I say my array and then put a period after it, it's going to give me a whole bunch of interesting things that I can do with this array. Specifically in this case, we're looking for length, and I love how it just defaults there. So we're going to put my array.length in here. Now notice how I'm not adding the equal sign here. If I put the equal sign here, I'll get an out of bounds exception because length is going to be 6 because there's 6 elements in my array. I initialized it to 6. If I go to the index of 6, I'm outside the bounds. So it'd be my array 6 right here. Whoops, 6, which is out of the bounds. It's actually going to crash my program. Now it won't stop me from running my program. My program will still think it's all valid code, but as soon as I get to this line, it's going to crash it. So that's why we're going to keep this as just less than, not less than or equal to. So in here, let's go ahead and print. Now, a common error that I see in a situation like this is a student will go like this, my array 0. So they'll go through the array.length and they'll print my array 0. But when we print this, we get 5, 5, 5, 5, 5, 5, 5. You know, we only get the first value because we're printing the first value. Now, if you remember from our iterations video, with a for loop, we have this nice nifty variable here that we can use, I. I starts at 0 and it goes to, in this case, 5. So I want to use that variable in place of 0 to say I want to print out every single given index of my array. So when I run it, I can see the values. Now, this in itself is not exactly much more, streamlined when it comes to something like this, but let's try it another way. So if you recall, let's go ahead and comment this out. If you recall, when I was at this point, it said array creation must have array size or array initializer. The array initializer can be done immediately after the array in curly brackets. So right now I'm creating an empty array with nothing in it, but the compiler is happy with it. This right here is never going to run because I is 0 while I is less than array.length. Array.length in this case would be 0, so it'll never actually run. But we can put some stuff in here. So we're going to put 5, 2, 10, 9, 15, 10. Very, very simple, very straightforward. I can remove this stuff. Now you're starting to see where this becomes much more streamlined, much more straightforward, much more usable for a programmer. I'm going to run my code and check this out. We have 5, 2, 10, 9, 15, 10. So exactly what we had before, but it's much cleaner. Again, for every single extra character I add up here, or extra integer I add, I have to go through and add one line here, one line down here. So that's 2 extra lines of code. And here, I mean, I can go for ever, just doing whatever I want to do here. I just added a whole bunch of characters, nothing's different. When I run my code, it's actually going to print out all those new values. So that's the value of an array. Now, I just made it very appealing to create an array like this. However, oftentimes you don't know what data is going into your array prior to you creating it. So let's get rid of this again, and let's initialize our array to size, let's do 5, let's keep it simple. So right now, previously, I said my array 0, yada 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 like that. What if that's not the case? What if I as the user, or what if I as a developer want to allow the user to input data into the array? Well, let's do that. So I'm gonna first off say hello to the user, and I'm gonna delete all this code. This code is no longer needed. I'm gonna say hello user, please enter 5 values to input into the array, integers only. So let's go ahead and create another for loop. So I'm going to say for tab my array dot length. Now I'm going to come into my for loop body and I'm going to say console.writeLine, enter the value at index I. So what this is going to do, I'm using I here because remember I starts at 0 and it goes to 5. So I'm saying enter the value at index 0, index 1, index 2, index 3, so on and so forth. So I'm informing the user exactly where they're going to be putting this data. And then I'm going to say my array, if I can spell. And remember, I'm putting I here. I'm not putting 0, I'm not putting 1, I'm not putting, any other number. I'm putting I. I want to use the looping variable as it's supposed to be used. Equals int.parse console.readline. And then after we're done with this, we're gonna give the user a thank you message. Hey, thanks for inputting your code here or inputting these values. Thanks for inputting your values. Here they are. And then we're gonna print them out. So let's go ahead and run this code. So it's gonna say, and let's actually clean this up a bit. I'm gonna say write, and I'm going to plus a colon at the end there. So all I did there is I made it so when I enter a value at index whatever, it's going to put a colon at the end. I'm going to be typing immediately after that point, like this. So instead of typing down here, I'm typing up here. So hello user, please enter 5 values to input into the array, integers only. So enter the value at index 0, 5. Enter the value at index 1, 2, 10, 15, 9. Thank you for inputting your values. Here they are, 5, 2, 10, 15, 9. So the same way I printed before, I'm going to print it again. So I've now stored this data in the array, and it's much more easily usable than trying to create, 5 different variables that just become a huge mess. So when I was a teaching assistant at the university, I would often see a lot of times people using just multiple variables as opposed to using an array. For example, one of our classes we created a Pong style game where multiple balls would spawn and you'd have to manage them all at the same time, and kind of neat little addition to what Pong is. I would see many people who would create variables ball 1, ball 2, ball 3, ball 4, ball 5, and just create up to ball 10 because that's what they kind of expected the user to be able to like max out at. Anyone going past 10 balls, they'd eventually lose one and they'd be able to recycle from there. And their code was atrocious. There were so many extra lines of code that were needed. Whereas when you use an array, if these were an array of the balls in the game representing the actual objects in the game, then you just loop through the array and do what the ball needs to do. Every single ball needs to be updated. It needs to move around the screen. With an array, you just call on the array and then you update each ball in the array. Very, very simple, as opposed to ball 1 dot update, ball 2 dot update, ball 3 dot update. It becomes a big problem when you don't do it this kind of way. So let's go ahead and take this one step forward. I'm going to go ahead and comment this out, and we're going to come down here. So something I like to use is random. I like randomly generating things. It creates, something more interesting than me just hard coding a few values in here. So our system class up here, now remember system has, console, and it has all these other fun things that we've been using. System also has a random object. So I'm going to say random, rand. So random is the type, the class name. Rand is the name I'm giving it. So I can choose, whatever I want here. I'm saying rand equals new random. So I'm going to create a new random object. Now I can also seed it right here if I want to give it an actual seed. This will guarantee that every time I run my code, it's going to have the exact same numbers generated from it. And this is really useful when you want to run a test and verify that I run a test, change something, tweak it, see if my algorithm is better, something like that. You want to test on the same data, but you don't want to manually type in all that data. Seeding the value is really nice there. But we don't want to do that. We're just going to have a random seed, so it's going to give me random numbers all the time. So let's create another array. I'm going to say int, let's say my other array. Since I already have my array named up here, I'm going to give it a different name. And I'm going to say new int array of size 100. So let's create an array of size 100. Now, just like we did right here, I'm going to say for tab, my other array dot length. So I'm going from the first index of the array, and again, I say first, when in reality, it's the 0th index. It's still the first index in that array, up to the length. And I'm going to say my other array, I equals rand.next. And then I have a few overloads here, so min value, max value. I'm going to say between 0 and 100. Let's just do that, keep it simple. So now my other array is going to be an array of size 100 that has random values between 0 and 100. So just like we did before, tab, my other array dot length, console dot write line, my other array I. So again, I'm just iterating through the array again, and I'm printing every single element in said array. So I'm going to run my code, and you can see here we have a nice set of randomly generated numbers. It's funny, 1 landed on 1, that's cool. So we go through here, and you'll find duplicates, you'll find things like that, you'll find, it's random, it's literally random. So you're gonna find some duplicated stuff. So this is what's useful with an array. I just created 100 integers in no time at all. Writing this took very, very, very little. Especially, since random's nice. You don't have to actually think, oh, I don't want to create patterns or anything like that. Let's do it again. How about 1,000 elements? Let's create an array of 1,000 elements. I literally added 1 0 to my code. 1 0. And check out how easy this is. I now have an array of 1,000 elements. Now it's, I'm going pretty quick here, but trust me, there's 1,000 elements here. So you can see here how I change one bit of code and I get a very interesting different result. Very useful, very expandable. When I'm editing my code, when I'm going through modifying my program, it's very easy to modify through the use of an array as opposed to creating 1,000 different variables. It'd be an absolute nightmare. So now that we have our random array generated with 1,000 elements, let's kind of skip forward a few units to algorithms. Let's write a few semi-interesting algorithms that will do something with this array. Specifically, I'm going to come down here and I'm not going to bother printing out the array. So this creates the array. The other for loop that I just deleted was printing the array. I don't want to print it. I'm going to type to the user. I'm going to say, what value do you want to search for? 0 through 99. And the reason I say 99 here is because when I say ran.next 0 to 100, technically this is exclusive. It doesn't actually include the 100. If I wanted the 100, I'd have to put 101. So matter of fact, let's go ahead and do that. So what value do I want to search for 0 to 100? We're going to say int input equals int.parse console.readline. So they're going to input a value they want to search for between 0 and 100, assuming they put in 0 through 100. So let's search through the array and see if we can find it. Going back to our iterative statements, this is when using these loops really makes our code much easier. I could say if my other array 0 equals input, then print this, yada yada, but that'd be a nightmare. That's where for loops really come into play. That's really where they have their power. So for tab, I'm going to say my other array dot length, and I am going to say if my other array I is equal to input, console.writeLine. But yet we're not going to print in this. We're going to do algorithms in this. We don't want to print in the algorithm itself. We want to store some data and then print after the fact. So I'm going to create another variable called a Boolean is found. We're going to call it is found. Did we find what we're looking for? And we're going to initialize it to false. So if this is the case, we're going to say is found equals true. So if we found an index where our other array index matches our input, we're going to say we have found the data. Then we're going to come down here and say if is found equals true, console.writeLine, you have found the value, and let's go ahead and put the value in there, input in the array. Oops, there we go. So now here we're going to do an else. Now we could do an else if is found equals false, but that's just a bunch of extra code. A true false is either true or false. It's one or the other. So no matter what, we know for sure this code is going to run exactly the same as this code. So let's just simplify it. If it's found, print this. Otherwise, let's print this. You have not found the value in the array. So let's go ahead and run that. And what value do you want to search for? Let's search for 42. You have found the value of 42 in the array. Great. This isn't really helpful for me. It's helpful. I know it's in there. I don't know where in there. So let's go ahead and modify that. So let's create another integer called index. And we're going to initialize this just to 0 just because. Now, if I find an element, we want to say where we found it. So we're going to say index equals I. Now remember, I'm not saying index equals my other array I. My other array I is the actual value itself. So it's going to equal 42. I don't want to set the index to 42. That's what I'm searching for. I want to say I found it at this index. So in my isFound, I'm going to say you have found the value input in the array at index. So now when I run it, let's hope we find 42 again. Okay, so you have found the value 42 in the array at index 858. So, you know, the likelihood, I have 1,000 elements, I have 100 elements, I'm searching for one. The likelihood that I'm going to find the same element multiple times is pretty high. What we're doing in this code is we're going through and we're looking at every single index. So we're going to go through 1,000. Let's say this was, you know, let's go ahead and do this. Let's create this to 1,000,000 elements. Now this is actually going to take some time. You can see, okay, so did you see how there was like that little latency there? How it took a minute for what value you want to search for to pop up? That's simply because this was an expensive operation. I was creating a huge array. And I can show you a little trick here in a little bit that'll demonstrate, you know, how much space I'm actually using on my computer. It's really kind of neat. But what value do I want to search for? I'm going to search for 42 again. That was actually way quicker than I thought it would be. It went through search the entire array, but it found at the very, 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 very end. So very, very towards the end, it found my object or my value, and it's done. You know, and again, like I said, it was faster than I expected it to. We checked a million elements when in reality, what if the first element itself was 42? We don't want to bother checking the rest of it when the first element is 42. So we can do what we call breaking a for loop. When our for loop is doing some logic, which this for loop is doing, this for loop is trying to find a value. It's searching for a given value in the array. When we want to break this, as soon as we found it, so once we find it once, we want to do just that. We want to break the for loop. So now before you saw it was like 99999, it was a huge number, something like that. So I'm going to look for the same thing. You're going to see index 8. So as soon as I got to index 8, I broke the for loop and I didn't continue running it. I saved a lot of processing power. Let's say our for loop wasn't just this super simple if statement. Let's say it was doing something interesting. You know, why would I want to continue here if I've already found what I needed to find? Why would I do that more expensive operation over and over and over again for 1,000,000 elements? You know, it'd be a big waste of time. So now, because I want to show you how kind of this stuff works in the environment, I want to show you something really cool. So this will be something that we get to in class itself. That's a little bit more advanced for what we're doing right now. But I just want to show you how to think like a programmer. Think what your code is doing, why it's doing it, what resources it's using, so on and so forth. So I have 1,000,000 right here. I'm going to create an array of 1,000,000 elements. As soon as I create this array, you can see here that I'm using 11 megabytes of memory. And again, this is the diagnostic tools built into C#. This is a very well built in Visual Studio. It's really, really useful when you want to do something very interesting. However, so remember before how I said, you know, a long is twice as big as an integer? Well, let's do that. So I'm going to run it again. And when I run it through the debugger, I'm pressing F5, I'm not pressing Control F5. Now you can see it went up to 15. This is because the process itself takes up some memory. 1,000,000 elements of an integer, you know, you can do the calculations on that to see how much it takes up. A long is going to take up literally twice that amount. So let's change this back to an integer just because I want to keep it nice and simple. And let's change this to, you know, 10 million. Let's change this to 100 million. Let's give this a go with 100 million elements. So I'm going to press F5. I'm going to drag this over here. So you can see here, it created a very, very large array. This is 0.5 gigabyte of memory. If I run my task manager, you can see here that this is using a lot of memory. It's actually using less than it says. That's probably some weird Visual Studio diagnostics things. But the program itself is using a lot of memory. Now let's check this out. Let's try 1 billion elements. Let's just keep going. Uh-oh. We have a problem. Now I ran that with Control F5. Let's run it with F5. we don't have enough available memory to create 1 billion integers on my machine. Now, my machine has 16 gigabytes of RAM. It has enough, but Visual Studio has put limits in place to where you just can't create, absurd amounts of memory. But let's try this. Let's try a short. Now, I'm not actually sure if this will work. I think it will. We're going to need to cast this to an integer now. Or sorry, we need to cast it to a short. And we're going to run it. So check this out. Because I used a short, we're between values 0 and 100. We know for sure we're never going to go outside those bounds. So there's no reason for us to try to use an integer to use a long. By using the short, and again, I'm literally allocating space. It took that long to allocate that array size. It's 1 billion elements. It takes a while. You can also see here, I have a 4-core machine, so you can see this is roughly a quarter of what the CPU power is. I was maxed out 1 core on my machine using that much processing power to create a huge array of 1 billion elements. And I'm taking up 2 gigabytes of memory. So when I bring up my task manager here, we can see that I'm using just that. I'm using roughly 2 gigabytes of memory. This is a lot of memory that I'm going to be using in this application. This is why, oftentimes if you're running the game, it's running slow, you check this, you have memory leaks or something like that. Memory is just getting allocated. It's getting added to the process that, am I using 1 billion elements right here? No, absolutely not. I mean, I could, but there's no reason for me to use it in this scenario. So now we have this algorithm that searches through our array. It's kind of neat. It allows us to search for something. If I was to bring this down to, let's say 100, and let's give it a few tries. So I'm going to look for 42. So I found the value 42 at index 48. So let's try it again, 42. I have not found the value 42 in the array. Because it's random, I might find it, I might not. Specifically because I put myself at 100 elements. At 1,000, at 10,000, you're much less likely to find something that doesn't actually exist. So let's go back to sort of what we had before. We're going to comment this code out. And we're going to take this code right here, and we're going to print it. So if you remember, this code just goes through the array. We want my other array. This code goes through the array and just prints the values. So when I run it, I'm going to get all these interesting values. But these are out of order. I just randomly generated numbers. They're not in order. It's hard to kind of tell. If I wanted to see if we had 2 of the same number in here, I'd have to go through and look. It'd be a pain. Let's go ahead and sort this array. So there's a video on YouTube called 15 Sorting Algorithms in 6 Minutes. It's also known as the sounds of sorting. Now, I'm going to play this video for you. This is a bubble sort. This is the algorithm that we're going to write. And I'm going to play it at 0.25 times speed so you can kind of see what's going on. Now, you can see here how multiple of these bars are red. Don't take that as what's going on. In reality, only 1 bar is actually being selected at any given time. This is just YouTube, breaking down the video, making it, as this is going full speed, it looks like it's only selecting 1 object at a time. But I'm going to go ahead and play this, and let's kind of watch what's going on. So you can see it's going through, and it might look like, at first glance, it might look like it's just taking the biggest element and bringing it down here. But in reality, what it's doing, a bubble sort is going through and it's gonna swap values. So for example, right here. So in these 2 values right here, and imagine this being an integer where the taller it is, the higher the integer is, something like that. Right here, we're gonna get into a comparison. We're gonna compare the left side to the right side. The right side is lower than the left side, but we can see that we want the highest values to the right. So what it's gonna do is it's gonna swap these. So I'm going to play this, and it might swap that one with that one as well, but we'll see. So you can see here it actually brought it down, and it swapped another value with it. So it's going to continuously go through and swap values, swap values, swap values. The reason for that was it actually brought this value right here up to this, swapped them, swapped them, swapped them, swapped them all the way down. it's kind of hard to explain because this is going so fast. So let's just sort of watch it, and then as we program it together, we'll look at it more closely. So you can see it's starting to build a sort of pattern. That's what bubble sort does. It builds a pattern towards the shape of the array. Now let's go ahead and increase this to normal speed, and let's finish the run. So once we get towards the bottom, you can see, these are basically already sorted as is. These are basically sorted as is. It's building it together slowly as we go. Now keep in mind, a bubble sort is one of the worst sorting algorithms you can do in terms of efficiency, but it's the easiest to understand. That's why we're going to implement it. And then eventually we get to the point where we have a fully sorted array. So that's what we're going to do here. We're going to go back to our code, and right here we have the code that randomly creates an array of size 100, and we randomly create the array, or we dynamically create the array with 100 elements. We randomly set the values of the array, and then we print everything out. So right here, let's go ahead and bubble sort. Matter of fact, I want to keep this file pretty spread out. So let's take this out. We're going to keep this right here like this. We're going to take our random, we're going to just put it at the top so everything can use it. And we're going to come all the way down here to the bottom. Oops. So now I'm going to say int array to be sorted. Let's call it that, equals new int array. And let's make it 100 elements just for now. Remember, we're going to design this in such a way that we just have to change this one number, and we can try any number of array that we want. So for tab, array to be sorted dot length, and I'm going to say array to be sorted I equals ran.next 0, 101. So we're going to store a random value between 0 and 100 in our array. We're then going to go down here for tab, array to be sorted dot length, console.writeLine, array to be sorted I. So we're just going to do the same thing. So we're going to create the array. We're going to dynamically allocate, different random elements to it, and then we're going to come down here and we are going to print the array. So now let's sort the array. Let's use a bubble sort. So the way the bubble sort works, and again, this is kind of skipping forward to our algorithm unit. We'll talk about this a little more in that unit, but I want to demonstrate it because it's so valuable for arrays. The way bubble sort works is it works on a swap, by swapping two elements. So let's say I have int a equals 5 and int b equals 3. Assuming we're going in least to greatest order, b should be the higher value. Imagine this being, like index 0, index 1, something like that. We should swap these. Now, in order to swap these, we need to use a temp variable. We actually need to store this. There's no such thing as saying a equals b, b equals a. If I was to try to do this, I would set a to equal to b, but then I would set b equal to a. So these would both, in a nutshell, just equal whatever b equals. At the end of this, they would equal 3, both of them. We need to create a temp value. So I'm going to say int temp, and I'm not even going to initialize it to anything. I'm just going to create temp. So coming down here, I'm going to say temp equals a. I'm going to store the value of a. I'm then going to replace the value of a with b. So a equals b, and then I'm going to put the value that we stored from a, the original value of a, in b. So b equals a. This is the basis behind a swapping sorting algorithm. You need to create a temporary variable, store one value in a, or in temp, swap the two next values, and then put temp back into where it needs to go. So we're going to be using a lot of this. However, we don't want to just do that once. We want to do that many times. We want to do that for every single element of the array. So that's where our for loop comes into play. So we're going to say for array to be sorted dot length, And then we're going to go through and we're going to do the swap. So, but remember, we only want to swap if a certain condition is met. And remember our conditional statements? So if array to be sorted I is greater than array to be sorted I plus 1. So we're going to be comparing the left to the right. In our video that we watched, the two bars right next to each other that we use as an example, this is going to be the left, this is going to be the right. So if this is the case, we want to swap them. So we're going to say int temp equals array to be sorted I. We're going to store back into I, or the array to be sorted index I, the value of I plus 1. So equals array to be sorted I plus 1. And then we're going to store temp back into this value. So I'm going to copy this, paste this, equals temp. Cool. So now we've created one iteration, one pass through of our bubble sort. So let's go ahead and modify our code. So I'm going to say console.writeLine starting sort. So this will kind of break it up, and I'm going to put a console.writeLine here just to break it, and here to break it as well. Oops, too many. There we go. So I'm going to copy this. After we sort it, I'm going to print it down here. Now, I know that this isn't going to do exactly what we want, but I'm going to run it anyways. And you know what? Let's simplify this to be 20 elements, just so we can see more of what we're looking for. Now, I also know that there's a bug in this code, a bug that will come up here in a minute. But let's go ahead and run it. So I'm going to run the code, and we're going to get this. So we're going to get our 20 elements on completely unsorted, and then we get this unhandled exception, system index out of range exception. Now the reason for this is right here. Anytime you use a for loop with the value I, you need to be very respectful of the upper and lower bounds, specifically of something like an array. Now, because I'm going to array.length, array.length plus 1 is outside the bounds of the array. If the array is size 20, that value will be 20, and remember, we start counting at 0. So an array of size 20 is indexed from 0 to 19. So if we say 20 in there, it's going to be out of bounds. It's going to throw us an error. But because we know the way our algorithm is working is we're swapping values, we know that there's no reason to actually check the last element. The last element will be checked when it's being checked by the previous element. So right here, we can subtract 1. That will fix our problem in this scenario. So we're going to run it, and we're going to get this. So we see 7, 13, 92, yada, yada, yada. But we can see here, this is our array here is still out of order. What this is going to do, this is one iteration of our loop. It's going to, as in the video, the red bar swept across over and over and over again. What we did was we swept across once. So you can see here how bubble sort, because it's constant, it's starting at the beginning and it's going through. It's going to pick up the highest value that needs to be swapped. So we can see kind of a pattern here. We can see that if I make this bigger, we can see that right here it picks up 92, and it should pick up 92 until it gets to 96. So we come down here, 92 is nowhere to be found. 92, 92, okay, 92. So 96 was right here. So it picked up 92 and brought it as far as it could. Now coming down further, we get to 100. 100 is the maximum value that we can find. So based on our code, it's going to pick up that value and continuously swap it down the row until it gets to the very end, at which point it does exactly what we expect it to do. However, in this given scenario, we ran this once. How many times do we need to run this code to be complete? So let's go ahead and let's just put in a number and let's give it a try. So what I'm going to do here is I'm going to use what's called a nested for loop. So for tab, I'm going to say not I, I'm going to give this another value, let's say j. And that's j++. Let's give it a value. I'm going to give it 10. Let's just we don't know how many times we need to run it. We just assume we need to run it. And I'm going to put all of this code in there. So I'm going to run our code that we just had that was one loop through the array, and I'm going to run it 10 times. Let's see what happens. Well, you can see here's our original array, and you can see it's sort of sorted, but there's still a few issues here. For a bubble sort, you need to run this loop the amount of times that, or the amount of the amount of elements that are in the array. So if we have 50 elements in the array, you need to run 50 times. If you have, or sorry, 50 minus 1, you can still do this subtracted 1 here thing because you don't need to search the last time or sort the last time. So let's go ahead and do that. Let's say array to be sorted dot length minus 1, and we're going to run it. And you can see here everything is in sorted order. Now, we have something right here that's the same character, but it doesn't matter what order that's in, or the same integer. So this is the most basic version of a bubble sort. Because we have a nested for loop here, it's order n squared. It's a very, very inefficient algorithm when it comes to sorting, but that's okay. We're just sorting a few elements on here. Let's go ahead and do something like 1000. And we're going to run it. Okay, that was straightforward, and I pressed the wrong button, so I'm going to press Control F5. Okay, so 1000 elements you can see here. This is very nice, this is very pretty, this is very sorted. When we get to before our starting sort, you see everything's kind of all over the place. You can see that our algorithm indeed worked as expected. So, while ugly and kind of confusing, this algorithm, it's really rather simple. It's rather straight to the point. Go through the array, swapping elements. If the left is bigger than the right, swap them. Go to the next index, try again. Go to the next index, try again. Once we get to the end, go back to the beginning and just rinse and repeat the process. This is how you saw those patterns get formed in the video. So this video has already kind of gone over budget a little bit, but I want to show you one last thing before we stop. In this example, I was only using integer arrays. An array can be literally anything. Let's say I want to have a string array, my strings. I'm going to say a new string array, and I'm just going to give it an initializer list. So I'm going to say, hello world, my name is Ryan. Cool. I've just created an array of strings. Now, just like we did before, I0, I to my strings.length. I'm going to console.write, write my strings I. And now also I want to add a space at the end because I didn't put a space in these words. So when I run this, and let's go ahead and comment out all of our other code. We don't need ran, so we'll comment that out. So we're going to run this code and see what happens. Hello world, my name is Ryan. And now, after this we do a console.write line. And let's run it. Hello world, my name is Ryan. So I just printed out a string array. This is a string, this is a string, this is a string, this is a string. I printed them out and I put them all together. If we were to put write line here, we would get what you expect. Hello world, my name is Ryan, all on top of each other. So that's going to be it for this video. In our next video, we're going to be talking about string manipulation. A lot of cool algorithms involve moving around strings, manipulating strings, doing interesting things with strings. It's how we can store interesting data. So I will see you all in the next video.